Getting started. Like I said, I've already looked at this a little bit, but we'll go through it together. This window contains information about everything in the game. You can move windows around by dragging and dropping the gray part of the window. You move around by dragging anywhere outside of the windows. To start programming, go to the first program page by pressing the following button. Okay, cool. Let's get to programming. Text editor. All programming is done in code windows. Each code window corresponds to a text file containing code. The code can be edited like in any text editor as long as it's not running. You can execute the program directly by pressing the green play button. When you run a program, the code flashes so you can see the execution flow. You can create more code files by using the plus button in the upper right hand corner, so we can click on this and make more. You can dock a window to another window by dragging it onto it. Oh, that's neat. Oh, that's cool. I didn't realize that. You will notice that once you start typing, a simple code completion window will pop up. Press tab to insert the code completion. Use the arrow keys to navigate through the completion options. Don't worry if this is your first time programming. The language is unlocked step by step, so you won't be overwhelmed by all the things you can do. The syntax is also similar to that of Python, which is one of the most widely used programming languages in the world, so learning it is not completely wasted. If you already know Python, it's not a problem either. You'll just be able to skip the early game quickly to get to the more interesting stuff. Code is sequenced by statements that are executed line by line. Currently, the only statements you have available are harvest and do a flip. These are function calls. A function is essentially a piece of functionality that can be executed. You execute it using the parentheses. Try typing these statements in the code window and pressing the execute button. Unlocks. Selecting grass will give you hay. Hay can be used to unlock loops in the unlock menu. Open the unlock menu with the button in the top right corner. Okay, see, I missed this. Selecting grass can give you hay. You can use to unlock loops. Nice. He's playing your game. All right, so first thing is, when you see this, I start typing and it shows up, you just press tab and it auto finishes it. This protects you from capitalization errors and it protects you from spelling errors. And then we can just hit do a flip. And look, our drone with the cowboy hat does a little flippy. We don't give a shit about that. We want to harvest. Want to make some money. Bloop! Look at that, he's doing the thing. And then we just sit here and we click this like a crazy crackhead. Or we can do this. And now it does it as fast as we can. Then we just gotta click it again. Boom! Awesome! We're awesome programmers. Hell yeah, we're executing a code. Some method. Harvest organs. You want to permanently delete F1? Yeah, get FO out of here. No! Harvesting organs, Dustin. You're not taking me to Candy Mountain. Unlocks a simple loop. Wow! All right, so we spent five hay. What hay? Your hay. 5 hay. Hefe? Hefe! We're the boss! Hefe! That's a different game, actually. True. You have unlocked the while loop, and the value is true and false. While condition, and then do the body. Don't worry about creating infinite loops. The delays in the execution will prevent the program from freezing, as if it didn't, then it would just fucking crash. For beginners, perhaps you've already tried to make several harvest calls in a row. We did! I didn't the first time, but we did the second time. This allows you to harvest several times in one program run. However, it would be nice to harvest more than 3 times, and writing the same code multiple times is bad practice. It's bad practice. I'm bad. The solution here is a loop. Loop. A loop allows you to run the same code multiple times. The while loop takes a condition, which is logical value that can only be in one of 2 states. It's either true or it's false. Such a value is called a Boolean value. The loop then executes the code inside the loop, and the condition is false. Then the while loop looks like this. Woo! We have to replace the condition with a Boolean value and loop with whatever code you want to do. There are 2 constant Boolean values available. Constants are values that never change during the program. To create a constant Boolean value that is always true, you can just simply write true. Write false as a constant Boolean value will always be false. So you can either write this thingy or that thingy. The first will never do a flip, and the second will do flips forever. Here, while we're reading this, let's get this bitch going. We're wasting valuable money here. Normally creating an infinite loop is a bad idea because it will freeze the program. But in this game, there are delays between each iteration of the loop, so it will cause the drone to keep doing a flip until you manually stop it by pressing the execute button. Again, he's talking about this one up here. If we wrote that, which we didn't, right? We wrote the one that gives us stuff instead of the one that does a little flippy. Notice how the line after the colon is indented. Indentations like this is used to separate blocks of code. Just press tab to add an indentation and shift tab or backspace to remove it. The loop will repeat all indented statements after the colon. Statements after an indented block will be executed after the loop is finished. So like if we had something like down here, like do a flip, this would run when the loop finished. But that's the thing, this loop will never finish because it's on while true. It never does anything. So this loop is just always going to keep looping. And because we've got it in a loop, we don't need to have multiple lines, so we can just have it like that. So yay, our program is small and fast. It's everything you could ever want. Awesome. Let's see what we can unlock now. We can make the drone faster, and we can get some grass. All right, drone's faster. It's significantly faster. The execution speed has been doubled. The problem is that the drone now harvests faster than the grass can grow, resulting in no harvesting at all. Do with this, we have if branches, and the can harvest function is now unlocked. Yeah, so see, it's not there. Like we're getting 0 money now. So here's some if and then a condition. The can harvest returns true if the plants under the drone is fully grown and false otherwise. So we can go while true, harvest, but we only want to harvest if we can harvest. And then now this needs indented because in this language, indentations mean that this is under like part of this. If this was at the same level, then it would do nothing. So you can see like this can be demonstrated actually better like this. Demonstrated like this. So if we can harvest, then we will harvest. If we can't harvest, then we'll do a flip. So, oh, this needs a colon. Boop. Boop. Now this is wasteful, right? But this highlights the if thing. So if harvest, and then at the end it does a flip. Actually, this always does a flip. Never mind, this doesn't highlight what I wanted to highlight. Sorry. And then we can do else, colon. So if it can harvest, it harvests. If it can't harvest, then it does a flip. Now that's much smoother. So there we go. Awesome. So for beginners, the if... Oh, you can only see the top part because my big ass head. All right, I'll make sure to keep things up here when I can. The if takes a condition just like the while loop and executes the code block if the condition evaluates to true. And so since this returns true or false, this is going to, be the condition. So here it has an example of doing the flip. And you can also add an else that defines what to do whenever it comes to false. So whenever this is false, we do the flip. And that's pretty much the code that it has right here. Else if is short for to have another one. You can have multiple checks if you wanted to, but here we only have 2 options. So this is just how we're doing. So if we only had true and false conditions, which is of course not very useful, then you can do it like this. Else if self-destruct. No, Dustin, no self-destructing. The reason you can use this function as a condition is because it returns a Boolean value. If it didn't return true or false, then this doesn't work. But this one does. So, now it just talks about their code. All right, cool. We don't need this stuff. Let's go ahead and drop this off, and we can run it. And now see it's streamlined, and the exact moment that it's available, then it grabs it. Awesome, awesome, awesome. All right, let's double the yield of the grass. So now each one is giving us 2 instead of giving us a single. Cool. We can increase the speed, but that takes wood. And we can increase the value of the grass, but we don't have enough yet. All right, let's unlock plants. What do we get here? Grass is nice because it grows automatically. All other plants have to be planted with the plant function. The only plant you can plant right now is a bush. Oh, shit, we're gonna plant something that takes down towers. Thank God we don't have any towers around here right now. This will plant a bush under the drone. Clear to reset the farm to all grass and reset the drone position. Nice, I didn't realize this. Cool, so, let's make it so, actually you can write code over here. And because it's not running, then we can like have a backup over here. So we can, if we harvest, else, then we can go plant entities bush. Nice. And now we can just take this. Actually, we can just run this. Oh, keep forgetting those. Now we can just run this. And so it can't harvest it, so it's waiting, it's waiting, it's waiting. Grabs it. And now we're making trees. Wow, we got wood. Jet fuel can't melt steel beams. Right, it can't, but it can make them all bendy. Like my wet noodle in the morning. All right, senses. The drone can see what's under it and where it is. Wow, we can expand. Wait, expand costs 30. I thought this said it cost 300. I'm thinking of the grass upgrade. We can upgrade the grass. Let's do census and expand in combination. Let's first expand and read what we got. And let's go back to harvesting grass. So we'll this. Oh my God. We can do a clear up here and then the wild true. So it always resets at the start of each run. That's kind of neat. And while we're here, I'm going to grab the grass upgrade so we can get 3 per grass while it's running. And while it's running and we're reading. So we unlocked the farm. Now there's 3 things, but we're not using them. What the heck? So wasteful. Your farm has grown. This space is not much use if you can't move the drone. So here's a new function. Move. Why is it wet? Why are you? Because it's getting hot in here. I mean, if it wasn't getting hot, it's only getting hot because it's wet, all right? Come on now. So we'll unlock the new function, move. So that moves the drone. Move requires that you specify the direction in which the drone is moved. There are 4 new constants for this, north, east, south, west. So for example, move north. We'll move the drone in 1 square to the north. If you move over the edge of the farm, the drone will be moved to the other side of the farm. This is really nice of them for helping people who are learning to program. Because then you don't have to worry about checking it yourself. They're going to handle it for you. The following example code will keep moving north and wrap back to the start when it reaches the edge. All right, awesome. So let's do that. If we can harvest, then harvest. And if we can't, then let's move north. And now watch. Look at that. It's more streamlined because it's grabbing the next one while the last one is growing. Wow! This is pretty cool. This is called a parameter and an argument. So it's annoying that they're 2 different things, and I forget which is which because they mean the same damn thing, basically. I think the way it's set up, if I remember right, which I don't, the argument is what you provide it, and the parameter is what it takes. Something like that, or it could be vice versa. Either way, this method takes a direction, right? That could be a parameter. That could be the argument. And now, for that argument, we're going to provide it a value, which is north. That's the parameter. So this is being provided into this method. Your methods can take in data. And that allows it to, change the behavior, which is really cool. So this one function can go north, or it could go east or south or west. It doesn't have to just do one single thing. Like can harvest can only do one single thing because we're not providing it anything. It's also possible that it has a default if nothing is provided. So neat, we've got a method set up. And now census. Things are gonna get crazy. The drone can now see. We gave this thing a camera. The function get position X and get position Y. Return the current X and Y position of the drone. At the start position, they are both 0. The X position is increased by 1 every tile towards east, and the Y position is increased by 1 for every tile moving north, but it starts at 0. Number of items returns how many of an item you have. For example, number of items hay will return how much hay you have. Get entity type and get ground type return the type of entity or the ground that is under the drone. Once you've unlocked operators, you can check if the drone is over a specific entity or ground. Once we have unlocked it, we don't have it right now. Do a flip if you were over a bush. Would be like, if the entity type is a bush, then you do a flip. The none keyword is also unlocked now. None is a value that represents that there is no value. So this is null from other languages. For example, a function that has no return statement actually returns none. Get entity type returns none if there's no entity under the drone. Neat. Alright, well, now we can do something like if can harvest, and then we're gonna just go like, I'll do it like this. If get position Y equals 0. Wait, we can't do checks right now, can we? No, we can't. Well, that's annoying. All right, so here's how we're gonna do this. Because we don't. Yeah, I know. Oh. Shut up, you ding-a-ling. I know it's not ready yet. I'm working on it. We're just gonna go plant entities bush. We're just gonna plant a bush. That's what this program does. Boop. All right, so we got a bush here. Nice. I'm gonna remove this clear because I no longer want to clear it. we're going to say if get entity type. Get entity type. Just like it has set up over here on the left. Entities.bush. Then we're going to do the if can harvest. Oop. Harvest. And then we gotta put the colon here. I gotta put a colon up here. And then else. Plant. Entities. Bush. So if we can harvest it, we're gonna harvest it. If we can't, then we're gonna plant a bush. And then it's gonna kick back out, and we're gonna try to harvest and then harvest. Then no matter what we do, at the end of it, we want to move north. Now this is gonna be kind of shitty because I already know some problems with this, but this is what we're gonna be running now. What the fuck? We still don't have the thingy to do the thingy. Because we don't have the equals check. That's funny. I was trying to check if it equaled 0, and then I realized I didn't have the equals check. So then I tried to check if it was a bush. Silly me. We can't do this until we have that check. Can we buy the check? No, we can't buy the check. Damn it. Go back to the farm. Is this going on my resume? It could. It should. All right. Well, we're just gonna harvest this gosh darn bush. Run this one. Else plants. We need some bushes. Entities.bush and then move north. All right, cool. So we need bushes. How many bushes do we need? Or rather, we need wood. It doesn't run in the background. All right, cool. We need 30 wood. So we're gonna do this until we get that unlocked. My dad may get my youngest bro a summer internship at my plant for accounting. Nice. Then there'll be 4 of us there. Wait, what? Wait, what? How many of you? I thought. Who's the third one? All right, operators. Arithmetic, comparison, and logic. You've unlocked the ability to use expressions that work like Python. You can do math, you know, add, subtract, multiply, divide. What the hell is a double one? Modular and ampersand. Comparisons is equal, does not equal, less than equal, greater than equal, less than, or greater than. Boolean, not and or. All numbers in the game are floating point numbers, so all arithmetic operators are floating numbers. / is defined just at the floor of the number after the division. Okay. For assignment operators, you need to unlock variables. Okay. For beginners, operations allow you to perform operations on values. The arithmetic, like math, are used to perform common math things. You can add and subtract stuff. Makes sense. You should know all these things. Now, you have a percent sign. This is one that you probably haven't dealt with in like school and being a basic person. But it's just the remainder. So, it essentially divides the number and returns the remainder. You can also think of it as repeatedly subtracting the right number from the left number until you can't do it anymore. So, like 4 modular 2 is 0 because it's even. 5 modulo 2 is 1. And 6 modulo 2 is back to 0 because 2 goes into it evenly. So this modular 2 lets you check if it's an odd or even number really easily. And then it shows here that it's always bringing what's left over. So in 1.1, mod 1 is just going to bring the 0.5 because that's what's left over after you keep subtracting 1 from it. All right, now we can use these comparison things, like if it's equal to or does not equal, to evaluate the true or false instead of using a method that just always comes back as true or false. So as you can see, 2 equals 2. That's true. 2 does equal 2. Fun fact, in case you didn't know. Or bush does not equal bush is always going to be false because a bush is a bush. 3 does not equal 3 plus 1 will always be true because 3 plus 1 is 4. So 3 will never equal 4. And you can use like less than and greater than. So 1 is less than or equal to 1. That's true. 2 is greater than or equal to 3. That's not true. Yada, 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 yada. The logical operators can also called Boolean operators, the not, the and the or are used to combine values, so you can do 2 checks at once. So you can think of this as not false is always going to be true, and not true is always going to be false because you're just saying not. It's simply the inversion of it. And And an and value, if obviously true, only if both things are true. So like true and true, that's true. True and false, well, that's not true. It's not and true. True and true. False and false is also false. Because it's not, and is not comparing the values. False is equal to false if you did an equals to equals, but false and false is not true. And then the or just means something has to be true. So you can have true, and then I'm in the way for here. But or just means something has to be true. So true or true would be true. True or false would be true. False or false is still false. And that's kind of shown down here. Behind my head. I could move myself, but I'm not going to do it. All right, cool. So let's do a clear. And then we'll go back to the get position Y. That equals 0. So if we're in the first row, then I want to do a can harvest, else plant, and then we're gonna move. Because see, this move is outside of it's outside of the check. Right? So no matter what side we go down, it's going to move. And actually, I don't need this here either. Here we can go if not can harvest. So the opposite of a harvest. Can we harvest? Can we not harvest? If we cannot harvest, then I need to plant this bush. Let's go ahead and move this up like this. So if we can harvest, we're going to harvest. And then if we're in the first spot only, if we cannot harvest, we'll plant a bush. So that's how this reads. And that's a really cool thing about your methods. When you make some on your own, which will eventually unlock, the key thing is to make it read like English. So if we can harvest, harvest. If our position is 0 and we cannot harvest, plant a bush. See, like you can kind of just read through the code, and that's a really important thing when it comes to naming your methods. Right now we can't make methods, but we will unlock that functionality before too long. You don't want your method to just be A. Execute A. What the fuck does A do? I don't fucking know. It's A. Figure it out. Ask the question. Answer. I don't know. Asshole. Who knows? It could be anything.